Hello, good morning. This lesson today, guys, is on 10.5 tangents of circles. This is your first officially new material coming back from spring break. So again, up to this point, we talked about 10.1, which was on, what is a circle? What are the parts of a circle? 10.2 was on angles and arcs. So we talked about the central angle. We talked about the arc measure. We talked about arc length, which was a piece of the circle circumference. This particular lesson is on tangents. Now, not the same tangent from like SOHCAHTOA, opposite over adjacent. The tangent of a circle refers more to a line, which I'm going to cover on this next one. So basically what I'm using, guys, are notes from last year, and I'm just going to walk you through these completed notes. So you can watch this video as many times as you want, okay? So what is a tangent line? It is a line that is tangent to a circle. It's going to cross that circle exactly one time. Okay, so that point where it's going to cross is called the point of tangency. So you'll see in this picture right here, where I'm using my cursor, this entire line right here, that would be called the line that is tangent to the circle, the tangent line. And it's touching the circle exactly one time right there. So what we would have discovered, in class, if we had been in class physically, was you were going to use a ruler to draw that line to be a perfectly straight line. And then you would use a ruler to connect this point of tangency with the center. Okay, we talked about this term the first day, which is called the radius. And then what I would have had you guys do is use the protractor to discover what's happening here and what's happening here. Hopefully you're noticing it looks pretty darn close to a right angle, which it is. So the first of two theorems for today is right here. If a line is tangent, then it is perpendicular to the radius. Okay. Now, as far as notes goes, guys, obviously it's up to you. All right. So if you would want to write these down, I would absolutely do that because I am going to be assessing you in some way. It's going to likely be some kind of a quizzes or another digital format like that. So if you have a printer, great. You can attempt to print something or look up other videos, but I would definitely have paper and pencil handy at this point, writing a few of these things down. Maybe even a couple of the examples we're going to do. I'm going to walk you through 6 of them to be exact. But that's the first theorem, that a tangent line is always perpendicular to the circle's radius. The first 2 examples here, let me zoom in so you guys can see a little better. All right, on this first one up here, what I gave you is obviously in the black portions here. So I gave you the radius is 5 from C to D. I also gave you that from D to A is 8. So that means this entire length would be 13 because you add the 5 and the 8. You're allowed to assume in all these examples that this line, in this case AB, is in fact tangent to the circle. So I drew in the right angle measurement here. And since all radii are congruent, that's how I was able to label the length CB also as 5. I want to know what AB is, so I called that entire length X. And then I just do Pythagorean theorem because, again, it's a right triangle where you're given one of the legs and the hypotenuse. So I solved that problem over here. I will go through this a little quickly just for your guys' time to value it. And that way, those that need to help, watch it again, you can go back and forth if you wish. But over here, I solved that problem and I got a Pythagorean triple. The value of X was going to be 12. In example 2 down here, I gave you, again, the radius just from F to D was 9, which means also D to E is 9. I drew in the right angle measurement here. I also said that E to G is 12. If I want to find the length of DG, I labeled this whole entire thing X. And look at that. This 9 in particular right here doesn't actually get used anymore. I'm just going to use this 9 right here and this 12 with Pythagorean theorem. So 9 squared plus 12 squared equals X squared. I gave you yet again another Pythagorean triple just to keep the math a little bit more simple early on. The next one, come on. The next theorem here is the second theorem, where if you draw any point randomly outside the circle, okay, I just called it B. It doesn't really matter, but I called it B. If you create a tangent line from here to here, and then draw a second one from here to here,